Hello everyone, today I'm going to talk about the atom and electronic configuration. So this information is one you're going to use a lot in chemistry, and basic information you're really going to need to do whatever you're going to do in chemistry. So this is a simple model of an atom which you're going to encounter a lot. This is the nucleus. This is the neutron, which is neutrally charged. This is a proton, which is a subatomic particle, as well as a neutron, which is positively charged, and the electron is negatively charged. For the atomic mass, you're going to calculate protons plus neutrons, because each of them will have a relative atomic mass of 1 unit. So you're going to count each proton and each neutron as 1. The electrons, they're too small to count, so you're going to discard them. In the periodic table, you're going to encounter all of these little squares. Each of them represents an element, and it has the following information. The 11 on the top is the atomic number. It is basically the proton number of the element, or you can also count it as the electron number. But remember that an atom has the same number of protons and electrons, so the number of protons is equal to the number of electrons. So in this case, sodium has 11 protons and 11 electrons. But keep in mind that ions are formed when atoms do not have the same number of electrons as the same number of protons. The protons will always be the same for each element. The number of electrons, however, may change because an atom of an element might lose or gain electrons depending on the type of bonding that it's going to have with another element to form a compound. The number at the bottom is the element's relative atomic mass. So as I said before, this was calculated by adding the protons to the neutrons. So if you count this as 23 firstly, and rounding it up, and if you subtract the proton number, which is 11, from this number here, you get a 12, which is the number of neutrons that this element will have. So you're also going to encounter this type of diagram a lot. It's called dot and cross diagram. All of these crosses here, they represent the atom's electronic configuration, which is the number of electrons that an atom has, and it will be displayed in this following manner. This is going to be very useful for you to determine the type of bonding that the element will have with another, and it will help you look at how many electrons it has in general. So the first shell holds 2 electrons, always. And the next shell holds 8, and the next shell also holds 8. These shells fill up respectively. Sodium here has 11 electrons, so there are going to be 2 in the first shell, 8 in the second shell. 2 plus 8 is 10, and there is going to be 1 left in the last shell. We always call the last electron shell the valence shell, and we call the electrons on it accordingly as the valence electrons. The electrons in the valence electron shell are going to determine the element's characteristics. So sodium has 1 valence electron, and it's also in group 1. And the same follows for elements of the other group. So an element in group 2 will have 2 valence electrons. And the valence electrons are so important that in dot and cross diagrams, most of the time, you will only have the valence electron shell being displayed. This happens almost all the time, but mostly when the atom is so big that you're just going to waste a lot of time drawing all of the shells in the atom, and they're all going to be filled up anyway, so there's just not a reason to draw every single electron shell. So thank you for watching this video. I hope you found it helpful, and I hope that it cleared any doubts that you might have. If you still have any though, you can send a video request and we will make any videos to clear them. So I'll see you in the next video.